Assalamu alaikum. Hello, everyone. Today we will start the topic of basic programming concepts. So we will actually work with Python with focus on how to create and manipulate the data frames. Okay. So I will start with defining data series. What's a data series? In Pandas is a Python library that this library is used to work with data frames. You think of data frames as tabular kind of data. So in Pandas, series are labeled indexed one-dimensional arrays. So a series is a 1D array, okay, that is labeled or indexed. So you remember when we talked about tabular data in the previous topic. So we have a number of rows. These are the records or the samples, and we have number of columns. These are the attributes or the features. So every attribute or every feature is actually a data series. Okay. So because every one of them is a one-dimensional array. In fact, here, because NumPy arrays, when we were talking about NumPy arrays take only numbers, but here the element of each series could be integer, floating point, string, whatever. Okay, so it doesn't need. It's not only limited to numbers. Okay, the values of every attribute can be the type of the variables or the type of the values can be numbers as well as strings. The index may not be unique, so the same index, I can give the same index to different records. Okay, a collection of data series, if I have a number of data series, a number of features, a number of attributes, then that collection is called a data frame. Okay, and our focus here will be actually on data frames. Okay, so then let's come to a data frame. As I said, a data frame is a collection of series or attributes. Okay, so each one of them is a series. They all together form a data frame. So in order to create a data frame, following things are typically needed, okay? So we need n-dimensional array format. As I said, it's array format, but it's not NumPy array because the values can be strings. They are not limited to be numbers. So n-dimensional array, because we have a number of records and we have a number of attributes, okay? So every attribute, think of every record as a one point in n-dimensional space. So the dimensionality of the space is defined by the number of features or the attributes or the series or the variables. Okay, so every record is one point in that high dimensional space that's defined by the number of features or attributes. Okay, so we have the data, that's the actual data, and then we can add optional column title. So we add titles at the beginning. So we have titles or headers. So we have the actual data, and we can add titles or headers for the columns. So to define, like to title every attribute, and we can also actually, and that's optional, and we can also add labels to the different records. So by default, the labels of the rows and the columns starts from 0, 0, 1, and so on for both rows and columns. If we don't specify column titles and row indices or row labels, the default titles and labels are just the index starting from 0. We will see this actually, okay? So for example, let's look at this here. We want to create an array, we want to create a data frame, okay, from this array here. Okay, we use the word array here, but we don't mean here really a NumPy array, okay? It's just a array. Think of it as an array or 2D list, okay? Can take numbers as well as strings, okay? So we're gonna construct a data frame or create a data frame from the content of this array. So how do we do that? This is actually a hard-coded data frame. So where we enter the values here manually, okay? So we call the function data frame. So first we import pandas as PD, okay? And then we use the the pandas built-in function data frame here in order to create the data frame. So pd.dataframe, and here we're passing the content in a 2D list. This is a 2D list. Okay, so let me do this here. Okay, this is not an numpy array. This is a 2D list. Let me bring this. Oh, what did I do? Okay, where is the here? Let me go back to here. Okay. Okay, sorry for that. Okay, I wanted to bring this here. Okay, let me just minimize this then. Let me do this. Okay, so come back here. Okay. So if we take this here, okay, say A is equal to this. Okay. And then we write, okay, so what I'm doing here, that's okay. Type A. Okay. Okay, A is a list. Okay, so let me do rent type A. Okay, so it's a from class list. Okay, that's A. So this is a 2D list. Okay, so we have the outer brackets. Okay, and then for each row we have its own brackets here. This is a 2D list. Okay, we're passing the elements here, we're hard coding them. They are strings here, as you can see, and then we're adding labels for the records. Okay, row 1 and row 2, and we are adding titles for the columns, column 1 and column 2. So that's the syntax. Index is equal, and you pass the labels for the rows, and columns is equal. Inside the brackets, comma separated, you pass the titles of the columns. So, and we use display here, not a print. Display def, I will tell you why. So this is it. So we run it. So as you can see here, so we have the titles of the columns printed here, the labels of the rows here, and this is the content. Okay, we can use print to print it out, but actually display is a more beautiful way to display the data frame. So it still can be printed out, but this is a more of a beautiful way to do it. Okay, these are options. As I said, if I, for example, don't want to define index, I can still run this, and then it will take the default index 0, 1 for the rows. Same thing for columns. If I don't want to define columns, this is what will happen. So 0, 1 are the default titles of the columns. Okay, so these are the indices of the columns. So if you want to access the first one, we will see that later. Okay, we can access it by passing the title or the index of the column and the row. We will talk about that later. Okay, that's the simplest way. So that's a hard-coded data frame. Okay. Now let me go to the next cell here. So here we are creating a data frame from, let me zoom in again. Okay. We are creating a data frame by passing a data frame of size 1000. This is the number 1000 times 3. 1000 is the number of records or rows, and 3 is the number of columns or attributes or features. So that's the size of the data frame, and the elements of data frame are randomly generated following the uniform distribution. So we're calling and from this is now we are creating this data frame from a numpy array. Okay, the first one was from a 2D list. This one is created from a numpy array. So we're calling the function np.random.rand, and this generates a uniformly distributed random variable between 0 and 1. By default, is between 0 and 1. If I, for example, want it to be between 0 and 10, then I multiply here by 10. If I want to shift it from 0, then I add whatever number I want to shift with. Okay, but by default, if I pass it like this, then this function will generate random variables between 0 and 1, uniformly distributed between 0 and 1. And this is the size. The number of rows would be 1000 and the number of columns would be 3. So here we are passing titles, okay, to the 3 columns, column 1, column 2, and column 3, and then we are displaying them. Okay. So here is the data. So there are 1000 records. So it's not showing all of them. So it shows the first 5 and then jumps to the last 5. Okay, because that's going to take a lot of space here. Okay, so as you can see, the numbers are all randomly generated between 0 and 1. Okay. In reality, actually, we don't really generate data frame by hard coding the elements or generating random numbers, because actually we work with data that's collected for a long time, so it's stored in some kind of format. Okay, it's stored in a file. Then you need to load that file and read the data in that file and create or construct a data frame for it. So in this course, we will focus on 2 types of the files. The CSV file, CSV stands for comma separated values. So the values, the different elements are separated by comma, and the Excel file. So here we will see how we create a data frame from the content of a CSV file as well as an Excel file. So here we're going to play with this file. The name of this file is basic1.csv. Okay, we're gonna create a data frame from this, and we're gonna obtain a summary for the different attributes we have. Okay, we're gonna display the data and obtain a summary, and the summary depends on the type of the data. Okay, if the data in the file, if all elements of all attributes are from numeric type, then this is the kind of statistics that we will see when we run the command describe. Okay, when we call the function describe, we're gonna come to that later on, and I will explain the differences. And okay, so for the non-numeric data or the object categorical attributes, this is the kind of the statistics we will collect when we call the function describe. We're going to come to explain this in details later on. Let's start by loading the data and creating a data frame from it. This is the way. So we import pandas, and this is the function we call, okay, in order to create a data frame. This is a data frame we're creating. The f is equal pd dot. We call this function read CSV. We pass 2 arguments, the path to the file. Okay, this is the path to the file, including the file name with the extension, and the delimiter. Here the delimiter is comma, because for CSV files the elements are comma separated. In general, you can separate the elements with whatever sample you want, then you need to pass that delimiter here. So what will happen here, this function will read this file, will upload this file, okay, and it will separate all like attributes by commas. So all elements before the first attribute will belong to the all elements before the first comma will belong to the first attribute, will be the elements of the first attribute. The elements between the first and second comma will be the elements of the second attribute, and so on. By default, this function by default considers that the first row is a header row. It's for titles, so it's going to take the content of the first row as the header or the titles of the columns. Okay, let's look at this. We run it. Okay, this is the file. So the first row contains these elements, so they're not part of the data here, as you can see. The first row, the first actual record started from the second row. The content of the first row was taken as titles. So if you have titles, if the first row in your file contains the titles, then this is the way you should load and create the data frame. Okay, because this is by default considers the content of the first row as the titles. Okay, if you don't have titles there, then this is the command you will run. If you don't have titles and you don't want to add titles, then this is the one you run, excluding this here. Okay, run this. So header none. Okay, so this will read all the elements as data elements, no headers, no. So from the first row, it's gonna consider that's data. No, it assumes like no headers, no titles. So if we run this here, okay, so this is a separate file. So let me do it for this file. You see like what used to be the titles, they became part of the data. Okay, let me do it here. Okay. So, which is not desirable in this case. You should not include those as data, right? You see here, they were included as data because as values. I mean, the first three row for the data started from the first row in your file. So that's because we pass header is equal to none. Because here, by default, header is equal to true. Okay, so that's why we didn't pass it here as an argument, because we use the default value. But if you pass header equal to none, then you're not assuming, you know your file actually. You know, like you didn't provide any titles there, okay? You started the data from the first row. If you know that, then you should pass header is equal to none. You can actually, if your file doesn't have headers and titles, sorry, headers or titles, it's the same thing. If your file doesn't have titles for the columns and you want to specify titles yourself, you can pass header equal to none, and you pass this. Let me just okay, you pass headers equal to none, so you know like your file doesn't have columns, sorry, doesn't have titles, but you want to add those titles in the data frame. Okay, you want to add those titles at the top of the data frame. Then if you run this is what you get. You have generated those titles. Let's make them different from what we, so just to explain, like so we created these titles, so the file did not have titles, we created them here. These are the titles we created. Okay, so the file has no titles for the at the first row. Okay, is that clear? And I actually, this file is stored. I think the idea is clear, right? So we don't need to open the file. Okay, so okay, yeah. So here, as I said, we display. So this is the first part. So now we're back to the to this line here, because we know like the first row contains the titles or the headers. So we know that. So this is equal to passing this equal. Sorry, this is equal to like yeah. This means like, as I said, take the first row as the titles. Okay. Uh, yeah, so then this is what we displayed. Now we come to the output of this line here. Display the if.describe. So this is the description. Now, because now every attribute in this file, as you can see here, every attribute is a categorical attribute. So we got this kind of description, this kind of statistics. So the first here, so for each one of these attributes, this is what we return: the count, unique, top, and frequency. So the count is the number of times in which this attribute has a value. So for example, if this attribute, okay, has one missing value, like for example, one of the records, there's no value, there is no value entered for that attribute, okay, then this will decrease by one. Okay, so this is the number of records in which this attribute takes a value. Okay, it's not empty, so it's not the total number of rows, it's the total number of rows in which there is value for this attribute. So here there is no missing data. For each row, each one of these attributes has a value. Okay, because that's the total number of rows here. You can see the total number of rows is 1,278. So each one of these attributes has this much of occurrences or Yeah, I mean, yeah, this each one of them has no missing data. That's how I can explain it. Okay. The second one is unique. Unique means like how many uniques here, okay, for each one of them. So how many different choices or classes or categories for each one of the attributes. For example, for the first attribute, it takes either male or female. So there are two uniques. There are two classes, two categories. Okay, two choices for this attribute. For the other one, there are four. For the last one, there are three. Okay, so we have Hijaz, Central, and Eastern. There are three. It's a the third attribute is about the province. So there are three choices here, or three uniques. Okay, or three categories. The top is the mode, the one that is occurring the most. So for the first attribute, male is the mode or the top. So it has occurred the most. Okay, for the second attribute, which is the job type, white color is the mode, and for the last one, central is the mode. And the frequency here is related to this row here. So this how much we said male is the most occurring one. This is how much it has occurred, 875 times. Okay, and same thing applies for this. So this is like the frequency of the occurrence of the mode. Okay, now we come to reading from Excel file. Okay, so we have an example here. What the features are is not important now. They are like we have data with the number of features or attributes here. We have 17 attributes. Okay, whatever the attributes, that's not our problem now. So they are stored in this file. Okay, basic to it's an Excel file. So we're gonna load the content of this file, and we're going to create a data frame from that one. So simply we call this function, okay, read Excel. So that one was read underscore CSV. This is read underscore Excel, and we pass the path to the file, okay, including the file name with its extension. Okay, that's it. Then we create a data frame. This is the data frame, okay. So here we are displaying df.head, okay. We're not displaying the whole data frame. We are displaying the head. By default, this head function, if I don't pass a number here, it will display the first 5 samples, okay, or records. If I want to display the first 10, then I pass 10 here. Okay, so that's will display the first 10. I can also do the same for the, I mean, I can display the tail, the last 5. This is df.tail will display by default. If I don't pass a number here, it will display the last 5 elements, as you can see here. These are the last 5 elements. There are 39 elements or records or samples here. So we're displaying the last there are 39, sorry. We are displaying the last 5, okay? If I want to display the last 10, then I can just pass 10 here. Here we're displaying the first 10 and the last 10. As you can see, there is missing data in many of these attributes. There are many missing elements here where there was no entrance here. We didn't enter any number, okay? None, that means like this is, we have missing values here, okay? There's no entry for this attribute, for this record at this attribute, okay? So if we want to display 5 samples that are chosen randomly, okay, then we can call this function df.sample and we pass 5 here. If we don't pass by default, so you see here, randomly selected. The sample number 21, 1, 8, randomly selected samples. If I don't pass, any number by default will take 1 sample. Okay, so if I want to display 10 samples that are randomly selected, then I pass 10 here. And I get 10 samples that are randomly selected. Okay, so here, if we run this command here or call this function df.describe, now these features are mix of numeric and non-numeric. Okay, numerical features as well as categorical. So if we run df.describe, then by default it will only consider the numerical attributes. It will return the statistical summary of the numerical attributes, as we can see here. Okay, so these are only the numerical attributes. As you can see, C5 is not here. Okay, C5 is not here. C7 is not here because those are not numerical ones. As you can see, 7 is not a numerical one. 5 is not a numerical one. Okay, these are categorical attributes. So that's why their statistics are not included, okay, and describe here. So if there is a mix of numerical and categorical attributes, the if describe will return only the statistics of the numerical attributes. And this is what it returns. The count, the number of occurrences, the number, the number of rows in which C1 has a value, okay? That's here 39. So there is no missing data for C1, but actually for C8 there is so much missing data there. Okay, so C8 has a value only for 7 records out of 39 records. For the remaining records, there was no entry for feature 8. So we return the count, the mean, the standard deviation, the minimum, the maximum, and the 25th, 50th, and 75th percentiles. Okay, so this is the kind of statistics you will get for each one of them. Okay, seems like the means are within. Okay, most of them are within 1-digit number. This is large one. This is yeah, this is high one. But yeah, you can. Yeah, you can infer many things from the statistics. That's not what we're gonna look at for now. If we want to return the statistics of the object columns, okay, so the non-numeric columns, then we need to extract those columns first. Okay, we extract their titles first, and then we access only that slice from the data frame. And for that slice, we call the function .describe. Okay, this is how we do it here. So we call the function, the pandas built-in function, select data types, and we pass here include objects. I think you can also pass exclude numeric, if I'm not mistaken. Okay, so include object. Okay, then we're gonna select only these columns, and for those columns we return their titles. Dot columns, it will return the titles. So if I print this here, if I print the output of this here, okay. Okay, so these are the categorical columns. So we name this variable the categorical columns. Okay, so this will be a list that contains the titles of only categorical columns. So we call the function select data type. We include object type of columns, and for those columns we return their titles. Dot columns will return the titles. Then we will pass these titles here, because we can access different attributes in a data frame by the title. It doesn't need to be the index. So we're passing those titles here. So then we are accessing, we're not passing the f.describe. We're not doing this, because if you do this, then we are describing all the columns. But here we are accessing only this slice. Okay, the f of those columns. Okay, so we're accessing only this slice. Okay, only those columns. And for those columns, we call the function describe. Okay, so let's run this here. These are the columns, okay, and these are their statistics, the count, the unique, we explained those, top frequency and so on. So you can see here for this one, C5, the top occurring one is none. This is different from none. Okay, this is one of the inputs actually. Okay, it's none written. Okay, so for example, like if it's about, I don't know this is about what, but for example, assume it's about employment, and so if you don't know what's the job of a certain entry or record, then you don't leave it empty, you write none. Okay, so this is one of the desirable inputs here. This example could be confusing a bit, but this is not, this is different from none. This is one entry. Okay, yes, so these are the columns, these are the object type columns or categorical columns, and these are their statistics. Okay, yes, with that I think we stop here for today. We will continue the same topic next time. Thank you. Assalamu alaikum.